Well, today on the Zach Life, I'm working on a 100-year-old oil well. Almost. Well was drilled 1921. I guess that makes it 98 years old. I've seen the date. I don't recall the month, but the year was 21. The pump unit's not as old as the well, but it's an old unit. It doesn't have a serial number on it. It's an American. It's got some tags, but no serial number. I guarantee this thing's probably 1940s. Or older. The problem is it had a couple of seals start leaking in the high-speed shaft and knocked these bearings out. The gearbox still had oil in it. I was keeping it full of oil, but I guess the seal's leaking. It's got sort of a lip. It's hard to see. It looks like this sort of had a trough that's set full of oil. This gearbox doesn't really have an oiling provision or any trays or pumps or anything in it. And I guess it leaking, that one on the other side's actually one that thrashed. But I hired a welder to come out here. I was hoping this wouldn't be a big deal, and we just torched the brake and the brake net mechanism off of it so that I could get this bearing cap off without having to press this brake off, so we don't ever use a brake anyway. And it's not quite as straightforward as I had hoped. I don't know how well you can see, but the gear's not bigger than this hole, but once you disengage it from the bull gear in there, it's slid towards the back of the case too far to come out. All right, here goes. You can see the gear basically where it's hitting down here. I could pick it up a little bit, but I'm just going to take my rotary file and try to file a big chunk out of this side. It would be easier. My original plan was to cut this shaft off, cut this bearing off, and then file on the other side, take it out that way, and it would be easier because this would only have to go just a little bit. But the other side is the one that's got the belt load on it, and the load of this thing runs this way. So the load is actually on the top of this bearing, where the other one is more on the back. So I think it would be smarter for this side to file a chunk even if it's larger. Anyway, I'm gonna crank the welder up and get the file out. All right, 10 minutes into this, I gave up. What I'm gonna do is go get a drill, come back tomorrow and drill, need something I can point with, and drill a bunch of little holes, almost connected down to here, and then go to the other side and take a punch and just knock that chunk out of it. Well, just like that. is almost there. Alright, I think that thing's going to come out now. Oh my God, it's heavy. Alright, so here's what I've done. You can see there's a lip there that's gone. I cleaned this up with the rotary file. And let me get you back level here. Knocked a pretty good chunk out of it, but hopefully it'll work. I didn't actually have to knock any off of the bearing surface. This is just sort of a lip, I think, that's supposed to hold oil, which hopefully isn't important. Well, here's the gear. It's pretty good size. I think the size perspective probably wasn't super accurate, but that's a big old chunk of steel. All right, I'm back up here at my machine shop. I've got this thing stuck in here. As you can see, I welded all over it with hard wire. It had a small groove here where the seal ran. Of course, this is where the bearing sits. This is measuring 3-inch 543, maybe a crack under. I'm gonna want between 2.5 and 3.5 press, like 546. Anyway, we're gonna shoot this size here for 546. This original size here was 3.5. Now I got seals that are 3 7/16. This was 3 7/16. I'm gonna turn it down to 3 7/8. I'm at 3 3/8. We can just change the bushing on this real simply. Of course, the seal will be different. This will give us all good fresh meat. Then I'll flip it over. I have to probably put this in a steady rest. I still got to take this race off here, and then I'm going to turn this piece out here down to 3 7/16. Well, here's the deal. I have, without exception, every time previous to this, when I'll have to build up a gear shaft like this of unknown material, typically these gears are made out of pretty hard steel, I'll take these and put them in this lathe and turn them down and undersize them by 1/8 or 1/4 of an inch or whatever, a couple hundred thousandths, before I weld on them, so that when I machine them, the only material I have to machine is the weld metal that I put back on them. A lot of times where you weld, where the heat is applied to the original material, the original material will get fairly hard. Typically, in all previous times I can remember, that because you'll always meet the weld metal always has to meet somewhere, like where up against the shoulder or something, where you'll have to cut the original metal. It'll be hard, but it won't be uncuttable. This shaft was almost uncuttable. It was extremely hard. I didn't, in this case, turn down enough. I didn't turn down any metal before I welded on it, which was a bad mistake. This is the only one I remember that the material actually became super hard, and of course it's the only one I didn't turn down before I welded on it. The trouble I had, I went through a ton of inserts, as you can see through this clip here, which are about 12 or 14 bucks a piece. They're pretty expensive. But the biggest problem I had, it was almost uncuttable, but with a good sharp tool, it would cut on the seal surface
the hardness caused obviously a higher tool pressure, and the tool would sort of dig in a few thousandths where it had not been welded, and then would sort of ride up a few thousandths where the weld was, where it had been hardened. Also, the one ring that I welded where the seal sets was actually harder than the spot where I welded to put all the metal to build up where the bearing sets. And I think that's probably because where the bearing set had so much weld that the metal, the original metal, cooled slower than where I just had welded the single ring to fill up the groove that the seal had cut. It was just a single pass, and the original metal under the weld was obviously heated very quickly and cooled very quickly. Anyway, this isn't typically a problem. It's just a problem because I didn't take the time to do it correctly.
Got exactly what I wanted. It's just a little bit bigger, half thousandth or so right up against the gear, so I didn't sand as much. I'm gonna flip this over, set it on steady rest, and turn this where this seal runs right here down to 3 7/16 or whatever it was. Well, there it is. Now we get to go put it in. Yeah. That thing swelled a lot more than I thought it would. There it is. Yeah, it's still plenty hot. All right, I'm done for the day. This, I was hoping I could just put silicone on this. It's got to have a gasket here on this surface to work as a shim. This bottomed out, the bearing bottomed out, and this had probably 1/16 of an inch or so gap in it. Anyway, I'm about out of daylight. Anyway, about out of daylight. Sunset over there. I think I'm going to call it a day and work on this tomorrow. All right, I got a couple of gaskets made. It is the morning. It is tomorrow. That's what I meant. I'm gonna dump a little oil in it. Pick my tools up. I guess it's gonna be ready to go. I got the belts put on. Here we go. You know, I think I shut the almost goofed. No, it's open. Thought I left the valve shut. Blow something up. All right, here we go. Thing's tagging bottom. You can hear it. I think I left it like that on purpose. We've had trouble with this thing trashing up. So we left it just tagging. Well, there it is. I think it cost me about 500 bucks to fix it, and I spent probably, let's see, I got 5, I would say 4 to 6 hour days in it, half days, whatever. Probably saved me at least 7,500 bucks. Anyway, got her done. I'm gonna go look at the gearbox, make sure everything's oiled up real good. You know, I just sprayed a little bit of grease on those bearings, make sure everything's getting oil, and I'm gonna head to the next project.